So I think like maybe let's start with just kind of a quick overview of what the new-ish mass stretch code means and some of the highlights from that. So this is the new requirements effective for stretch code communities in 2023. So it's been a couple of years at this point, but still people are kind of getting around to understanding the idea and the new requirements, sort of all levels, I think, of the chain, from designers to owners to the AHJs and everybody. So maybe like, Gert, do you want to give us a quick rundown on what some of the key new requirements are that have not previously been on people's radar?
Yeah, so the general intent of DOER, the Department of Energy Resources in Massachusetts, is or was to more accurately, or have people more accurately calculate the actual loads for buildings, heating and cooling loads related to the enclosure, and so that mechanical equipment can be sized more accurately, like not ridiculously oversized. In order to do that, it's very we have to include now thermal bridging, the effects of thermal bridging, and also the effect of fasteners going through insulation, essentially anywhere where insulation is not fully continuous. There's multiple pathways that can be walked in the new code. For residential buildings, you can elect to use the passive house standard as a means to show code compliance, which in some jurisdictions is actually compulsory, such as anywhere where the specialized code is where a community has adopted the specialized code, you actually have to use the passive house standard for residential buildings above a certain size. And they also completely retooled whole building performance compliance pathways with new modeling protocols, which are substantially different from the old ones. New reference models you can compare your building to, which are a lot more stringent. That's in a nutshell an overview of the new code. It's still based on 2021 IECC, but it's just with a lot of amendments.
And Jake or Mike, what has been your big picture experience with this? Like, when did you first start kind of being aware of these changes, and what are some of the main tangible effects you've run into on your projects?
Want me to take it, Jake?
Sure.
Well, I think, like as you said at the start, Matt, this has been in the works for a while. But the 10th edition of the code, really the concurrency period with the ninth edition ends a month from now, right? We're recording this in May of 2025. So we were doing some of our old projects off the ninth edition, and only more recently have we started to do projects off the 10th edition of the code. And so I know Jake's been working through a project with you with these new requirements, and I'm working on a ground up project now that's been going since um, December of 2023, where we just assumed we're going to be on the 10th edition of the code, which was the right choice. So, we're starting to do it, and obviously we're going to have to do it on all our newest projects, but it's been about a year. I'd say a little over a year that we've been working this into our work here at Jones.
And how early are you typically incorporating this into your design process? Like, how early in your process does this start guiding design decisions?
Well, for the project I'm working on, we started thinking about it during SD, right? We had to talk about what version of the code are we planning to use. And then it kind of guided the assemblies that we were choosing and documenting during SD. It actually guided the proposal because we had to make sure that we had the right consultants on board, like a building envelope consultant, for example. And it's the lead project I'm working on, so a building envelope commissioning agent and so on. And it guided the principles of the mechanical engineering, the electrical engineering, if we're going to an all electric building with no gas. So it really did start from pretty much the first month of the project.
Yeah, we're finding a lot of folks coming to us kind of late in the game. And, I think whether they are finding out about it late or maybe didn't think about it as early as they would have in hindsight, but we kind of get involved towards the end when or the project options are a bit more limited in terms of addressing some of the issues. And that's been a challenge we've had to work through sometimes. And I think is probably something that will be fairly common, at least for a while, until people get their feet under them a little bit more with this.
Yeah, and I think the challenging things we all want a building envelope consultant to be involved as soon as possible to help guide the design. But our challenge, I think, is educating the client about why we need them and what they bring to the table. You know, was evident on this project that we just worked on, because this project started in, I think it was 2021, and it went on hold. And so we picked it back up, and it was like, just get to the finish line. We had already done DD, like, we just need CDs. And then you start looking into the code, and then it just kind of spiraled from there. I think one of the questions I had was, well, how do we go from a U factor of 0.33 to 0.29? And it's like, I don't know. We have to we have to model it. There's no, I can't say make the window, 25% larger. So I think that's a challenge on our end.
Yeah, that's something that we have been talking a lot about, is like what level of modeling makes sense in any given project, or if there's any sort of general rules or anything like that. Or maybe you can talk a little bit about that in terms of the different approaches of demonstrating compliance from BC Hydro Guide versus modeling versus those different ways to tackle that.
Yeah, it's in an early phase of a project. I think it's important to keep things very simple, model as least as possible. Where the BC Hydro Guide applies reasonably well, I think it's a valid assumption. Where it doesn't apply, I would thermal bridging effects with something that you feel comfortable with, that's probably just going to work, and then really look at the end result. How much buffer do you have in total across the whole assembly? And then if you feel like, oh, we're quite close, maybe less than 20% from the target, maybe do a little bit, like do an extra model to confirm some of your assumptions, but don't really go haywire with the modeling, because the modeling is of course costly, and is, like you said, where a lot of building owners don't understand why this is all necessary. You do of course have to do the modeling at the end, unless you can use something from the BC Hydro Guide. But the BC Hydro Guide has limited options, both in types of conditions, and they may just not apply because you've detailed your building in a different way. So it's kind of, you should do it, I think, progressively, like with the modeling, like start low and then ramp it up as you enter construction documents. But I think it's important to have somebody on board who can make a good estimation by really just looking at your details, and can compare it to their experience and other models that they may have run for other projects. Sort of someone who can more creatively interpret what's in the BC Hydro Guide, and who can extrapolate something out of it a bit more.
Yeah, it seems like that's where you can get a degree of value up front, where you're making these like low cost, high impact estimations early that have to be accurate, because if they're wrong, then you can end up in a bad situation later. But you don't necessarily have to spend, assuming you can do that, you don't necessarily have to spend the money on the really fine point modeling at the beginning, when you're still evaluating a bunch of different options, and you may end up modeling a bunch of stuff you don't even use. So I could see how that is like a reasonable approach, assuming you can do those estimations with a reasonable degree of accuracy.
Yeah, and of course there's like options with respect to design decisions, but there are also options with respect to code compliance pathway. Which pathway are we going to follow? Because there are, for any project, like 2, 3, 4 options. That is also something that a decision should be made relatively early, which path to follow, because it is going to impact that's actually going to impact the design potentially more severely, and also can change the consulting fees substantially. Maybe we could do passive house, or we could do prescriptive code compliance, or we could do the code compliance alternative, which typically was referred to as the backstop. That really, it just changes the calculus in so many different ways.
Can you explain the backstop in a little more detail? What does that mean? People use that term, but
the backstop essentially means that or at least under this new code, means that you can take your opaque wall assemblies and also all your fenestration and show compliance based on average U factor of those of fenestration and opaque wall assembly combined into one number that is, especially for buildings with a lot of glass, more lenient. But as the backstop is that you have to have your fenestration have a higher performance. So the U factor of your vision glazing has to drop from 0.3 to 0.25, which really pushes you into triple glazed performance.
That's exactly what we ended up doing on my project is we went with the backstop methodology and it pushed us into triple glazing assemblies. Not that that's a bad thing. It was just something that we had to deal with and detail properly with our assemblies. And I think what you said, Gert, about modeling things in therm or specific thermal bridges that you're concerned of, that's been our experience as well in this ground up project. Is we started with DC Hydro Guide, and not every assembly we drew was right out of the book, right? And so we made assumptions and we calculated opaque wall assembly percentages, and we kind of added them all together and showed that we complied. And we constantly look at that at each phase. After SD, we looked at it. At DD, we looked at it. Now we're at halfway through CDs. We look at it again, and then we look to see, oh, this assembly is causing us some problems, or at the roof is causing us some problems. Maybe we want to look into this one spot a little bit more specifically. And you can kind of really focus in on what your trouble areas are. Then you try and do it in an economical way, because you're right, you don't want to be modeling everything, and you're hoping that you're making good details throughout, and there's just a couple of problem spots at the end of the day.
Are you guys kind of just rolling this into your fee in terms of like, are you finding are you adding a line item? Are you just building it into your overall fees? Like, how are you presenting it to clients in terms of like, hey, there's this new thing we have to do that's substantial. It's not just a little uptick in required documentation and analysis. And I know you mentioned the storytelling, like explaining to the client what this is and why it's important. How are you handling that, and how you do that communication?
Well, Jake, I'll let you weigh in on how you did it. Sort of, I think it was a bit of a different process for your project. For mine, we lay out every consultant. It's a big project, so there's 20 something consultants. So the client knows that there's certain things that are required, and they know the new code is in full effect. The project's in Boston, so they also have their own enhanced requirements there. So they're no stranger to that. But Jake, maybe we do a lot more renovation here at Joe, and a lot more. A ground up building isn't as common for us, and so sometimes with smaller clients, it's a bit of a different storytelling thing. So I'll let Jake take it.
Yeah, on the project that we worked on, I believe it was just rolled into our proposal. It wasn't a separate line item. And I think the earlier we can educate the client on building envelope consultant is needed and what the cost of it is, so we can have that conversation with them, is important.
What have you guys experienced from the building code officials? Have they been asking you for this? Like, is it more of a pull, or is it a push where you've been almost more educating them and saying like, here's this thing we did, right? Are you finding them aware of it and asking, or is it more of you guys knowing what you need to do based on the new code requirements and just providing it?
You want to go first, Jake?
Yeah. I think it's us just looking at the code and seeing what's required and knowing that that's our duty, is to meet the code. And I think that one of the frustrations for us is we go through all these exercises to meet the requirements, but then who is actually reviewing this from a town perspective? Is someone reviewing calculations? Is somebody asking questions? Because most likely they're not. I think when we have lead projects, that's where maybe things get reviewed a bit more closely, because we have requirements that we have to submit and someone has to review them and sign off on them. So I think in that process, I think there's some more input from not necessarily building commissioners, but lead and other.
And I would say, in Boston, they have the BERDO ordinance, right? That kind of sets up tracking of some certain metrics. With this project, we have not interfaced with the AHJ on the energy code at all. It's been all about life safety, which is pretty typical. And I have some colleagues that work on the residential side, which is not what we're talking about here. Really, we're focusing on the commercial side. But on the residential side, maybe an inspector they're gonna ask for the HERS rating as a backup to close out the permit, right? And some residential architects are pushing towards passive house design and certification. I know that's the case for multifamily. We don't do a lot of multifamily or any here at Jones. Sort of, we haven't been asked for it, except that we know that we need to do it. And so I'd be curious to see what happens when someone starts asking for it and what that experience will be like. I don't have it yet.
It reminds me a lot of like NFPA 285, like 20 years ago or something, when people started noticing that the code required these tested assemblies for exterior walls. And all of a sudden it became this big thing where the knowledge just sort of started spreading, but it was a big surprise to a lot of people. Not everyone was asking for it necessarily, but some designers, I think, noticed that they should be doing that and designing that way. And then the AHJs started asking for it if they weren't getting it. And eventually it all kind of sorted itself out, I think. But seems similar to me.
I think the other part of it is like we're wondering, how do we include this into our drawing set? Are we adding the backstop, tables in? Are we just listing the values that we designed to in our assembly list? As we all know, there's a lot more that goes into than just saying this is a U factor of 0.3 or whatever it is.
There
Like,
is
who is verifying that? Yes, this is actually meeting that. Like, where does that
there,
information get added?
there is a new amendment to this code that tells you exactly how it should be documented now, which prior to that was an open question. They have like an attachment in the code commentary that lays out how you should provide the information. I don't think it is being reviewed thoroughly nowadays, even if that backup is provided. But at least I think they're gonna start looking for the backup to see at least, if it is there and if it somewhat makes sense. And you have to also cross-reference your details with that backup. So it does force you to do the right thing in a way.
That guidance is just in that recent February amendment, right, Gert, where they lay out the tables and things that they want to see.
Correct. Yeah. At least the requirement was added in February.
Right.
I think that the guide on how you should lay it out already existed before that. It's just that it wasn't being linked to the code as you should do it this way.
Right. Maybe when the submissions or a higher percentage of submissions start including the same kind of documentation, folks will notice and then wonder why it's not there in other cases. Start asking questions, right?
Yeah. I think over time, this code is going to find more support from AHJs just as much as we are trying to support this more and more. I think for both, it's a learning curve. And I think DOER knew that. They expected that. I don't think that's if you go to DOER and complain about, hey, your code isn't being enforced, they'll tell you exactly that this is going to take time, and we just have to do this, and we bit the bullet, and I think it's probably for the better.
Yeah, I was reading. Sorry, I was just going to follow up on that. Yeah, I was reading some of the provisions the other day after we submitted our most recent PD set to make sure we were on track, and there was one about air barrier testing, for example, and submitting like a requirement at the end of the project to say that this has been tested and that has to be submitted. And I think back to like, okay, well, when you close out a permit, you're required to submit your sprinkler test. So you're required to submit this test and that test. That would just be another test that is required to be submitted to close out a permit and check the box, I would assume.
In some instances, such a test is required. But not all projects have to. It's at the moment an optional test.
Right. Okay.
But in future codes, I could see that becoming mandatory too. Yeah, definitely the way the wind is blowing. But I think that testing is very valuable because it really pushes the entire industry to provide higher quality, both in design and in construction. Because ultimately, the building is only as good as what's actually built. The construction documents don't really matter that much for the owner. Yeah.
That's the beauty of the commissioning process when it's done properly, is that it combines both of those things, right? It gets the really sort of fundamental intent for the project very clearly documented early. It provides a mechanism for the whole team to ensure that those expectations are reflected in the design, that the documents clearly show all of that intent, and then all the way through into construction when you're doing observations and testing to demonstrate that the actual building does work the way everyone hoped it would from the get-go. That's kind of like the Goldilocks or the unicorn building enclosure commissioning idea that I think a lot of people sometimes think about it just in terms of the testing, but ideally it's hitting both of those things. It's hitting the design, the documentation, and then the demonstration of performance in the end.
And I think what we learned on the project that we worked with you on is that the smaller the project, the harder it is to meet the stretch energy code, because your building is so small, but there's no provisions for square footage of building. You're still required to meet all the new U factors and things.
Yeah, that's a really good point. I wonder if as time goes on, some of the, I don't know, maybe some of the documentation requirements or something might be adjusted for smaller projects, because the cost, I think a lot of the costs you're referring to are the costs for somebody to analyze and document that the design complies. And to do that, there's a difference for a small project versus a large project, but it's not linear. There's kind of a certain minimum amount of work that needs to go into it, even for a relatively small project, that starts to become a pretty big number relative to the overall design fee or the overall project cost, or at least it can be.
And you may even encounter, sometimes we're doing, Jake and I swap stories on a project that's essentially not an envelope project, right? And we have one wall we need to touch to put in a new entrance or something like that, right? It's just like we need a new door here. And that wall fell down by accident during construction. These things happen. And then you get to it and you're like, well, I have to put back the wall, and I have to put it back to be code compliant. And I need to meet the energy code for this, what is essentially like 100 square foot area. And with the rest of the surrounding area being from the 1970s, the 1960s. Right? And you want to do the right thing, and you put it back and you design your infill project, which is a bulletin to a project that's in construction. You're sort of scrapping it together on these small projects. They all can't be ground up constructions with a building envelope consultant and a building commissioning agent. And us architects do need to get to know this stuff front and back, even for the smallest thing.
Yeah, I was doing a warehouse building, it's all CMU and brick, it's just painted. And one section, there's a wood framed wall with a door on it. And we're replacing all the doors in the building, all the old fire doors. And this was one of the doors. And because it would be fire rated, we couldn't use wood. So we had to put CMU back to match the rest of the building. But now we're having to add insulated CMU and waterproofing, but it doesn't match the rest of the building. And to explain that to a client, and they're like, well, why can't I just put what's already there? And it's because this is what the code says and this is what we're required to do.
Yeah, it can be a lot of education for sure. I think there's probably a discussion too over time that will happen about where to draw the line between what is okay to stay the way it is and what ought to be brought up to more contemporary standards and aspirational standards. Gert and I have been talking a little bit the last couple of weeks about even the building that our office is in now. And that is an old mill building that over the past, I don't know, maybe decade or so, up until a few years ago was slowly renovated and is now a thriving community of a bunch of different businesses, from service firms like ours to retail stores and restaurants and things like that. It's a really great project for the town. I think it's been successful. A lot of people really like the building, and I don't know how if the project would have worked out had they had to go through the level of even just this thermal bridging analysis and making sure that all the enclosure elements worked from that standpoint. I don't know whether it would have made sense or not. It's a beautiful mass masonry, all exposed brick and timber and things like that. And to make that work and meet these requirements would have been a different project than what they did. And, it'd be a shame not to have this property in town the way it is. I think it's a good for the community and good for all the businesses that are in it. So I don't know. It's an interesting discussion, and it'll be interesting to see where that line ultimately ends up falling.
Yeah,
Very
it's
similar to our office. Yep, the brick wall behind me, the brick wall behind Jake, right?
Yep.
We replaced the windows recently to be much more insulated than they were, which was an old SAF window. But we're not going to spray foam our brick here.
Right.
Or the gaps that the wasps are getting in.
Right. maybe close those. Yeah. it's an interesting discussion. I think it's maybe that's worth a different podcast, but there's a lot to be said for, well, I mean, sometimes I think people in an effort to be quote unquote sustainable and improve, say, energy performance or something, end up causing harm to the durability or resiliency of a structure, right? If they don't understand how their interventions might change the way things perform. And also, is that sustainable? Probably not. And so there's a lot of factors that play in and are worth consideration, I think. And it sometimes, most often, goes beyond just numbers and tables and things like that. Probably preaching to the choir there on a couple of folks that work on existing buildings a lot.
Oh yeah, I mean, do I really want to mess with the vapor profile of a building and accidentally cause a condensation issue? No, I do not.
Right. Yeah, or cause a brick to start freeze thaw, damage, spalling and things like that.
Exactly. Yeah. Especially with this older brick, you never know, right?
Yeah. More work for building enclosure consultants, though, so I suppose that's all right. Lots of analysis there that can help keep those things from happening. All right, cool. Anything else you guys want to talk about before we wrap up?
Well, I think one thing not to lose sight of is that this code is trying to push us into doing the right thing. And one thing that can prevent large consulting fees are just doing the right thing and not designing thermal bridges or minimizing them to the absolute minimum. And that is going to drive designs for sure. It's going to influence the architecture. I think new buildings are gonna look a lot more like each other. Certain features are maybe gonna be off the table, right? Maybe we don't do balconies anymore, or we're gonna have one balcony that works that doesn't cut through the insulation. So we're gonna see that over and over and over again. Like that is something that you kind of already see with passive house buildings, how they, especially in Massachusetts, all kind of look alike. They're very simple, very boxy, dark glass, very, same wall assembly everywhere on all elevations. So that is something that I would like to know how you guys look at that.
I think to avoid everything looking the same, it's going to produce, manufacturers to start coming up with new technology that helps assist in these ways. And I think we're already kind of seeing it a little bit. Like when I was looking at glass manufacturers, just trying to get to the required center of glass value, I had to use their most efficient performing glass. Like they don't offer anything that's better than that, which is crazy because that was barely meeting code. So I think it's going to require everybody to, invest in technology and resources and creating better products.
Yeah,
hopefully.
and it's also going to require certain projects to be early adopters of those technologies, and some of those will sadly backfire, and others may be great successes.
Yeah, we had a vacuum glass, I think it was, manufacturer come in. You remember that, Jake? And we were like, okay, how many projects have you installed on them? I don't remember how many they named, but it was not a high number.
I think it was one that was being installed now.
Right. And so, obviously we were skeptical of that. We want to both do the right thing, and we also want to make sure that we're not providing something to our clients that's going to fail. That's with a liability thing, and it doesn't really help them out at all in the long run. So, I mean, it's a good observation that people may start picking up on details that work and just repeat them over and over again. I think it's our job as architects to both do that, do the right thing with a detail that works, but also try and innovate it, push the boundaries, and see if we can make something that looks a little different. So it'll be a balance for sure.
Yeah. And I think the other side of it is, architects are educating themselves, but then the next step is educating the contractors who are actually building these things because they haven't seen this type of, methods before maybe. And so that's another step
Absolutely.
in this process.
That makes a lot of sense.
Yeah, I did my passive house training last year, and they also have one for builders. And after that training, regardless if I ever do a passive house here at Jones, I think the training was really helpful for a lot of folks to take because it hammers home the importance of continuous air barriers, continuous insulation, good details. Passive house detail might be maybe boring, but it is important and really kind of got your barriers lined up in a row and your details. And I imagine, I met a couple of builders that took the builder side of the training, and they said it was eye-opening and changed how they did their practice too. So I do hope to see more of that. going forward.
Yeah, the education aspect of all of this is so essential. I just talked with John Straub recently, and that was the bulk of our discussion, was how the requisite knowledge to make these things work properly is just not as widespread as we might think it is or hope that it is. And those kind of trainings and others to just spread that message as far and wide as possible are really important. And I think we have a tendency to overestimate what the majority of people know and understand about these things. And so just really hammering those things over and over, and all of us being willing and continually trying to learn more and then to pass that along as best we can, I think is really so important to getting all of these structures to work better longer.
On that topic, are there good resources out there that you recommend for to learn more about building technologies, achieving these this?
Yeah, there's actually quite a bit of good information that's available for free online. There's also quite a lot of bad information, unfortunately, so it can be hard to parse through. Actually, on our website, if you go to CopelandBEC.com/self-help, self-help, I think, there's a list of some resources that we've found helpful. It is a problem in a way that the finding the right information is not necessarily easy. It is also a blessing that like this basic information itself is not a secret. Like firms like ours, and there's not this like cabal of people that have all the secrets and are withholding it from everybody, right? Like the building science, like the fundamentals of how to make buildings work well is not really a secret. People know how to do it. Some people do. It's just not widespread. So it's the matter of getting that reliable information into the right hands and widely available and recognized as reliable and reputable.
I think the concept of it is pretty simple, right? Like create a continuous line around your entire building with air barrier and insulation. But when you get into the nitty gritty, that's when it gets challenging.
So it gets fun. Cool. All right, guys. Well, I want to be mindful of our time, and I appreciate you taking some time to talk with us. And I think it's a good discussion. I look forward to talking more. Maybe we'll do a round 2 someday as we get more of these projects under our belt and can add, some more firsthand experience to the discussion. But this was good. Thanks a lot.
Thanks. Appreciate it.
Thank you. This was great.
See you guys.